Okay, so let's talk about the gas law, section 2. Sorry, this video is running a little late. So, hot air balloons work by heating up the air inside the balloon, which makes it less dense, meaning it expands, and it will then float or rise in the air because around the outside air around it is less dense, and so hot air rises, so the balloon will go up in the air. So, how are pressure and the gas of a pressure and volume of a gas related? Well, as one goes up, the other goes down. So, as we decrease the pressure, the volume will increase. So, they're inversely proportional. So, Robert Boyle was the person to study this relationship in a systematic way. So, he got to name the law after himself. And so, Boyle's law states that as a gas, for a given mass or quantity, we use now moles, but he talked about mass. For a given mass of a gas at constant temperature, the volume of the gas varies inversely with pressure. So P1 times V1 equals P2 times V2. So if we were to graph this, we would get a graph that looks like this. This is a typical inverse relationship. You might see this on something like an ACT question. If you see a slope that starts and decreases, it's in a curve. It is not exponential. It is linear. It's just an inverse relationship. And so we see as we decrease or increase the volume, the pressure is decreasing. So we do need to be able to do calculations with these. You will have a quiz at the end of this unit that will be kind of your last grade. So if you are exempt, you'll have that this week. If you are not exempt, you'll have that next week. So a volume contains 30 liters of gas and it's at 103 kilopascals. What will the volume of helium be if it rises to an altitude where the pressure is only 25.0 kilopascals? You're to assume that the temperature remains constant, which really isn't true, but we'll make that assumption anyway. So our knowns are the initial pressure and the initial volume and the final pressure. And our unknown, or what we want to find, is the new volume. So you would rearrange this formula solving for V2. So V2 will equal V1 times P1 divided by P2. And then we can substitute in our variables and we get that the new volume is 124 liters. And that makes sense because it went from a small volume to a big volume because the pressure went from a big pressure to a smaller pressure. So a decrease in pressure at constant temperature must correspond to a proportional increase in the volume. The units canceled correctly, so we do have the correct answer. So I want you to pause the video at this point, and I want you to try this calculation and see what you get. Okay, so going on. We solve for P2 in this case will equal V1 P1 divided by V2, and you should have gotten 141 kilopascals. And again, since the volume decreased, we should get an increase in pressure, and so that does make sense. So I think we'll stop here at Charles' Law, and we'll continue on tomorrow. Thanks for watching.